All right, here's 3 questions from the worksheet number 5, dealing with Dalton's law of partial pressures, which states that the pressure total in the system is equal to the pressure of each gas, partial pressure of each gas added up. And so, like in this first question, it says partial pressure 3 gases are 2, 3, and 4. So if 2 is the partial pressure of one gas, and 3 is the pressure due to another gas, and 4 is the pressure due to the last gas, then it follows that the pressure total in the system is whatever 2 plus 3 plus 4 is. So it'd be 9 atmospheres. And that was pretty easy because they gave you what the pressure of each gas is. We'll see in number 3, question 3, that we'll have to do a little bit more work to get that number there. Okay, the next question is a little trickier. It says I've got 2 moles of certain gases, 3 moles of some other ones. And they say, what's the partial pressure of each gas? Well, what you need to do is, using that same rule, pressure total in the system is equal to the pressure due to hydrogen, plus the pressure due to ammonia, plus the pressure due to carbon dioxide, plus the pressure due to nitrogen. Now, so each of those would exert a certain pressure, and they would each exert a pressure due to how many moles they have of that gas. So really, if I add up all of these, I can see what the total moles of the gases are. So moles that have 2 plus 3 is 5, plus 4 is 9, plus 5 is 14. So the number of moles total in the system is 14 moles. Okay, so to know what the impact of the hydrogen is, it only has 2 of those moles. So I could say for hydrogen, it would be 2 moles out of 14 moles. So that would be the portion of the total system due to hydrogen. So then what I could do is just multiply that by what the number is. 800. That's our total pressure, right? So hydrogen is doing 2/14 of the 800. So I do 2 over 14, multiply that by 800, see what that comes out to. Maybe I'll do that quick on my decimals here. So I've got 2 divide 14 times 800. So 114.3-ish. So the pressure due to hydrogen, 114.3. Oh, it looks like there's 3 sig figs, so I'd call it 114. And that would be the part due to hydrogen. And then you just do the same thing for the other gases. Okay, this next question is one, like I said in question number 1, it's really the same thing as question 1, but you got to do a bunch of work in order to get that. In question 1, they gave you what the pressure of each of the gases were and said, what's the total pressure? Here, they don't give me the pressure of the gas, but they give me information from which I can get the pressure. So take nitrogen, for example. They tell me how many grams of nitrogen I have. They also tell me how big the container is and what the temperature is. Let me just fix that right away. So I think that's 313 1 decimal place, so 313.2. You'll see in the calculation we do later that won't make a difference. So they give me grams, and from that I can find moles, and then I can use that formula, PV equals nRT, because I will know moles, I know temperature, and I know volume, and I know the universal gas constant, so I can determine the pressure. Let's do that then. So the pressure due to nitrogen, to figure that out, I'll do PV, maybe before that, let's do the moles thing first. So let's figure out moles. Moles are equal to mass over molar mass. the mass is 2.14 grams, divided by the molar mass of nitrogen. Since nitrogen is N2, one nitrogen is 1401, so two of them will be 28.02 grams. Let's figure out what that is. Okay, make that smaller. I wonder if that'll work. Okay, 2.14 divide 28.02. There we go. It's hard to read the number. 0.07637 moles of hydrogen. So now to figure out the pressure due to hydrogen, it's PV equals nRT, and I want pressure. So pressure is nRT over V. So my number of moles is 0.07637 moles. My R value is 8.314 kilopascal liters. Let me move that. Per Kelvin mole times temperature, 313.2 Kelvin, divided by the volume, which is 10 liters. So my liters cancel, my moles cancel, Kelvins cancel. I'm left with kilopascals, which is a pressure, which is what I want. Okay, so let's use decimals to figure that out. Now that first number, I already have. The 214 over 28.02 is that number there, so I'm just going to leave that there. So I'll times that by 8.314, times it by my 313.2, and then divide that by 10. Okay, there we go. So my answer is 19.887, etc. I think there's 3 sig figs, so we'll call this 19.9 kilopascals. So that'll be the partial pressure in that tank due to nitrogen. Now what I would do is go and do the next one. So the pressure due to hydrogen, I'll first find moles, mass over molar mass. That'll give me my moles, and then I'll use my PV equals nRT manipulated formula, plug in my new number of moles, and then solve for that pressure. In the end, this number here is the sum of those three. So it'll be the sum of this number plus the number you get from hydrogen plus the number you get from ammonia. All right, hopefully that helps you with those questions.